we did, but I'm still on it. And well, yeah, it's I guess it's a good learning. It's a good learning process. It's been good so far.
Okay.
Um, to get your hands on something to do, to rack your brain around it, try to um, connect the dots from drawing. Like I try to draw like a physical UML diagram to connect it um to my code. So yeah,
Okay.
so far so good.
Okay. It looks like you have a cold.
Yeah, I do.
Okay. Harsh. Give us an
Hello,
update.
Professor.
Give us an update. What you're
Yeah.
learning last week.
Well, the assignment of the last week was a good learning experience. First, I had some problems learning and working skill with the constructor and correlated with the uh, inner functions. But with the practice, I became more comprehensive and clear. I
Okay.
also learned.
Okay.
Hello.
Good, good. Go for it. Go, Harsh.
Yeah. Well, where am I? Mm,
All right. So you're getting familiar. You said you're working okay now with the Java code. Is that what you're saying,
yeah,
Harsh?
it's more comprehensible and clear. I also learned how to write a Java code and apply the use of constructors and relate it to two or more classes such as bank account owner's profile and address. The summit also allowed me to enhance uh, my object-oriented programming knowledge, debugging skills, and my faith VS Code as the tool to run in the Java code.
Okay. Are you
Uh,
updating your resume right now? You're a Java expert or not yet?
uh, Not yet. And sometimes I'm facing some problems on duty to push or apply the constructors in between two or three functions when we have like the different pages we need to construct with one page from the up to bottom.
Good, good. Okay. Well, we're moving along. We have a full semester to get it right, Harsh. Right?
Yeah.
Okay, good. Thank you.
Yeah,
Right.
thank you, sir.
Yeah.
Um,
There you go. There you go.
yes, I found it really insightful, but like second assignment was a bit too comprehensive or difficult than the first one. But I really feel the like progress, like relationship between classes and objects and new operators, arguments, and um, I'm excited to like um, learn more like about how to implement it in like real life projects. So
Okay. So you're saying, I can do this, right?
yeah,
Okay. Right. Remember, we try to learn design, but we have to get comfortable with the Java code, right? Really, it's syntax, it's annoying sometimes, it's unfamiliar, but really we try to simulate this idea what components are and how they work together, right? You're trying to build a mental model, how to be a problem solver, but you need to see it in action at the same time, right? But building that patience and saying, hey, this is not bad. Okay, very good. Thank you. Right. Uni?
Hi, Professor.
Hey.
Uh, okay.
There you go.
So yeah. I think last week's lesson is very useful, and also the assignment is also very practical that helped me realize that so when I was writing code, so I can realize the problem that like the first or second or third lesson that you talk about something like component, and also we watching you writing those codes, but it seems like it's not that difficult, but when we write it by ourselves, it's very easy to realize the problems, and I think it's very helpful that we have that kind of assignment. Also, I'm also taking Python class, so I think they are like very different. Like when I'm writing Java, I always need to write, the curly brace, right, and semicolon. Yeah, and it's really from Python. So yeah, but I think it's really helpful because I can practice. So yeah.
Yeah, two different animals. One is more mathematics.
Yeah.
They want you to focus on the math, but for us, we want to focus on the car, right?
Yeah. Yeah.
We want to make sure the car runs, right?
Yeah.
Right, that's the parallel layer, right? It's one is a function. You take input and you produce output, right? That's the mathematics thinking. F of x equal to y, right? But social life is not a function, right? It's chaos, right? So that's the reason we need to do that, because really application is a reflection of us, right? The application is doing who we are, right? Watching us inside the application running around doing stuff, and we're talking to ourselves, right? Inside the application. So modeling real life is very different, right? So these modeling techniques really try to capture the environment. It's like a building architect, right? They need to see the walls, they need to see the floors, the walkways, the heating, the air, right? These are utilities, right, that are useful. Same thing, the application is providing utility, right? How things become useful for us, right? For example, keeping one fun example you can have later on is just trying to figure out, making sure all the sprinklers in the classrooms are working, right? Right. So that you need the room, right, to figure out where the sprinkler is, right? And so those are different ideas, right? Object oriented is a way to capture, to model life and how who we are, right? While the other one is teaching you, just how the mathematics work for machine learning, and right. And we have the same thing right now with AI. What's AI? Is it the mathematics, that you do, the statistics, probabilities, or is it the agent that's doing work on your behalf? Right? Right. So these are different things. Okay. Thank you. And Hans Sheng?
Yeah, Professor.
Hey.
Last week's assignment truly a little bit more challenging than the previous one, and truly actually have more understanding of the concept of all the components, how they interact with each other. Like each functions provide different informations, and they gather in the documents and show all these things to us. And also, it's kind of a little bit challenge for me to have to use the environment of Java, and I did a lot of things to make it run.
But at the end, is it okay now? Are you comfortable?
Yeah.
We're still okay. Good. Thank you. Ray?
Hello, Professor. Hello,
Hey.
everyone. I think the last week's assignment is really a little bit challenged, and I really got crazy, a little bit of crazy at the very beginning things, because in the lecture and the lab recording, I think I know how to do the things, but it was another story when I began to implement it, when I tried to realize what something in my head into a Java code. That's the time. It's really the time I feel is hard, it's difficult. But I think from my perspective, I think that the last assignment, what is the main point is try to reuse the object or something the class, how to reuse it and build the relationships between the components for the different objects. Yes, and I think from the beginning to the end, we always should follow what we have built in our mental model. Yeah, and yes. Otherwise, we will get lost during the yeah. So I think it's good right now, but I still find something need to improve to optimize my code. Yeah, and it's a good opportunity to practice. Yeah, we always learn from practice and our errors. Yeah.
So the techniques are very, you're going to be using the same technique the whole semester is okay. So it's not, we're not jumping from one idea to another, right? So these techniques, how to connect components is really, right? Is pretty much all we do the whole semester. So these techniques are going to be comfortable. You're just going to do more of them. You see?
Yeah.
You're going to have more components. That's the only problem you're going to have. But the mental model idea, Ray, is important, right? Can you imagine a building architect with no mental model for what the building is, right? Right. So but the model itself, right, is going to drive the implementation, right? So always look at the component, how they interact together, and then say, okay, how they become code, how I can access one from the other, right? Those are where Java need to get into the picture, make it happen for you. But the whole idea is that, okay, we have a person that has 3 addresses, okay, right? I mean, very common, right, mental model about, yes, we do have these 3 types. And it's 2 components to interact to get together to capture, where the guy lives, right? Right. But so, we're going to continue this practice. It's still the same Java. And very soon, think in a few weeks, Java is not going to be the issue for you anymore. Right. But the lab is always going to help. Yes, you need to learn how to do this stuff yourself. And the lab is meant to be that, reducing the lecture time so you can do that. So, right. Because I always had this, Professor, when you talk, it's so easy to understand, but when I go home, I don't know what to do, right? But that's why they need the lab, right? So you can make this real for yourself. But the whole time I want you to appreciate your learning design concept here, right? Because the coding in the future, when you graduate, is going to be done automatically for you. But you need to, right now, we need to appreciate the code because it makes us more comfortable that we understand what design is, right? So because now I can convert a design to a piece of code, then my confidence in my design become very strong. And your confidence level is very high to become a good engineer, a good designer that way, right? Good. Good. Keep up the good work. Right? Yeah. And William.
Hey, Professor.
Hey. I hope I didn't wake you up, William. How are you?
I'm good. How are you? No, I got confused. I saw lab thought that was the class, but no, that's the lab on Thursday, not today's class. All good, all good.
Okay, all right.
Uh,
So
what was
what
the
was the
what was the
experience?
question?
Said what was the learning this past week?
I would actually say I did not struggle with the code as much as I thought I was going to. I like it's like you're saying, like it's more of like having the experience in like identifying concepts and identifying what makes a system, and I like already working on like we call in sociology we call it something we call it coding, but it's a different kind of coding, but it's like aligning attributes to certain things that don't already have attributes. So it's very similar. It's obviously it's not the same. We don't
Yeah.
transition that to Java code, but I mean it's the same idea. So then putting that into actual code this week, like it surprised. I was expecting it to be a lot worse, but surprisingly I was a lot more comfortable with Java than I was expecting to be.
Good, William. Yeah. Yeah, so I mean the whole thing what we're trying to do, right, with all this coding is primarily organizing things, okay, the same way, right? It's all organizing all these pieces of information. They need to go to the right place, right? That's so we can, and then, you have these different pieces of information that interact together to give you a bigger picture, right? But yeah, the same principles, right? Good,
Right.
William. Keep up the good work. Yeah. Right. All righty, man.
Hi, Professor.
Hey.
Hi,
Are you
everyone.
in coffee? Are you in coffee shop tonight as well, or
No, I made it home.
you
on
made
time,
it home? Okay, well, so there's no cappuccino involved tonight.
Fortunately, no.
All right. So what was the learning?
Honestly, I haven't finished the assignment yet, but it feels a bit more challenging than the previous one, but I'm not as worried because I feel like this is just part of the learning, that whenever you start something new, you feel that it's a bit harder, intimidating, but then you get used to it. So I'm more optimistic. I feel like with more assignments and more lab exercises, I will get the hang of it.
Yeah. So do
I'm
you
just glad that the class is not mostly about the code. It's about design.
Okay, all right. You found some time to meet with Rina, or you need more time to? Do you need help? Let us know so we can get you going.
It's okay.
Okay.
Yeah.
Okay. Very good. Thank you.
Thank you.
Giuseppe.
Hi, Professor. How are you?
Good.
Oh, hold on. There we go. I think, I don't know. The Java is interesting. The assignment, there's a lot of classes like for the bank accounts that you have to work with. So it's just like getting used to kind of all of that. It's different than Python a lot. But like others have said, it's just you get used to it the more you do it, I guess. So I guess the more you be getting into deeper things, maybe the stuff now will be easier a few weeks down the road. You know what I mean?
Okay.
But yeah,
You finished the assignment, or you're still working on it?
I'm still working on it. Yeah.
Okay. If you need help, let us know. Okay, Giuseppe. Yeah, just you need to go through it right now. This stuff is gonna be
Yeah.
easy. It's not hard, but you've got to get above this stuff. Things are gonna repeat very soon. We still have few more principles to cover, and then
Yeah.
you're gonna be, you're just gonna work on amazing applications. You're gonna be learning a lot more than you think by
Yeah.
just being able to see the model and then map it to code. This is what we're gonna do. Here's the model. Look at what it says, and now what does it look like in Java code? That's the whole semester will be like this. And the whole time is just being able to become good at understanding how to read these models very well.
Right.
And next semester, you get a little bit deeper in Java, but it's never really about getting fancy with Java, okay? It's just the minimum necessary of that programming language to do amazing piece of work.
Right.
So things are not going to get very complicated when it comes to Java. We need, the class, we need to understand the constructor, we need to understand methods, the attributes, and how relationships work between each other. Today we're going to get a little bit, a bigger picture than before, but still two components talking to each other, but for a little bit different reason. So there's some technicalities. Next 2-3 weeks, we need you to get to work with what we just gonna describe as arrays, and you will understand how arrays are, why they're important, connecting all these amazing components together. Okay, good, Giuseppe. Thank you. Li Ying.
Hi, Professor.
Hey.
I quite fully after heard the other classmates say, I quite fully related to what Rishan say, because for me at the beginning, I feel when I do this project, this assignment, I think I jumped into the coding stuff too early without fully thinking through their relationship. So I got lost and feel overwhelming during the process. So what I do is, and when I realize that I already lost in this maze, I just decide, oh, okay, let me start coding. And I went back and reviewed the slides again and thinking about their relationship, and which helped me clarify how the components are related. So after that, when I went back to the coding, I feel like everything became really easy because I understood why they connect to each other. So it's just like playing the Lego, and the contractor just put everything. This one should go there, and this one should go there. So that's what my understanding for this assignment. Yeah.
Yeah, I mean, that's a good way to put it. You put these Lego pieces together, right? And you see a picture of something, right?
Yeah.
Information is like that, right? Information, you get a good who did what, when, where, how, right? That's what you're trying to do with these pieces, right? Goodly. Sure, the team is listening to you. Fine. Okay. Very good. Thank you. Hao Shun. Thank.
Hi, Professor.
Hey.
So, what I have learned from it in the last week, so about the lecture, I learned about how to implement the relationships between the classes. We gotta have like the banking accounts from the lab on the last Thursday. So we learn about how Java works to connect and access objects and classes. So at the first beginning, I learned about the UML diagrams, then transfer them to the coding. But go back to the last week, we learned about the car. It's like a whole body for the car. But the last week is about the banking accounts. We have like more elements, more components about like owner profile and like address and contact information. So it's like a little bit more mixed for me.
Okay.
But I don't know how to say. Right now, I have been through like 1 month learning about Java and Python at the same time. I'm a little bit more kind of the Java person because in Java, I think it's kind of like you're standing like a bird view perspective to see a whole structure, a whole system, how to operate it. but the Python more seems like, as you said, it's like more you are fixing like a math problem or like a data problem to solve. So and the interesting is like Java, we can build many folded to build like more classes as we want, and we have like some very clear structure in every line. You can put you can put the type of the like string, integer to in front of every line. It's more clear than Python, because Python is like you already know that, but Java let you to write every type. So it's like a
It's life.
it's like yeah,
you
it's like a
know,
life.
right? There's so many things, right? We have onions, we have carrots, we have right?
Yes.
Vegetables, cars, different types, right? We're trying to describe life, right? Because the application is becoming a reflection of us, a mirror of us, right? But how? That's a good way to put it, right? At least finally, I got someone who likes Java better than Python. Good, right? But for all of you, you have to remember, right? Java, yeah, you're going through the initial steps of, getting beyond these technicalities. But for us, this technicalities is not the objective. Is the objective how to become a problem solver, how to engage in this AI world, right? You're going to be playing different kind of roles, but understanding what these technologies are. Like how it said, okay, now we know, when we're doing math, we need to do it in a certain way. When we want to do applications, we have to do it in another way, right? And building the right applications is important, right? Remember when you say, you get somebody, you call the university, say, oh, give us your phone number and last name and this, that. And then you call again, they ask for the same pieces of information, say, how many times do I want to tell? That's because of bad design, right? Right? So when you have problems with technologies, but not because technology is bad, it's just we're not building things, we're missing pieces of information, right? And the more we kept, the better we get the full picture of these Lego pieces, right? The more information we have that's accurate, right? So good, all right. So you're up to date with the homework assignment then? How?
Honestly, I have not submit my assignment yet. I'm still go through review the recording, but I think after you said, I got some inspiration of my assignment. Maybe
Yeah.
I will, like do some advice. So
Yeah.
then
Yeah,
I can
keep
read
yeah,
some.
you have to think, right? You have to think like, that you have your back is against the wall. You have no choice. The world is changing and we need to jump to this new world. We have to be ready. You're young, you have the energy now. When are you going to do this, right? Don't want to repeat it again. So go through the steps right now. You have an amazing support around you. Rina is there. I am there as well. And we're going to, and remember these techniques, we're repeating these techniques. Now you just learn them for the first time. Next few weeks, you're going to start using the same techniques over and over again. So just be patient. You have the recording, keep trying things. You guys, I've been programming for last 50 years, okay? And I was still debugging code this morning, right? And this evening I had to change some technique that I had in the morning, right? I had one technique, didn't like it, change it in the morning, and this evening I was changing it again, right? That's part of the profession. This is what we do. This is the world we're in. But by no means I give up. I don't give up. You don't give up. I have to build this. I have to get the excitement of the stuff. And now AI is everywhere, and you need to understand, when we talk about AI, there's a lot of noise. There's a lot of nonsense. But when you build good structure and understanding, so you can you can sort this stuff out. You know, the stuff is not, the things that you need to do are not going to be complicated. And, you know, I was talking to a software engineer yesterday, and he was telling me, oh, Professor, if I had these tools, he was working on a new product, but there was a delay in the product he was creating. He said, if I had these AI tools 2 years ago, would be amazing now what I can do. Because he was describing all the problems that he was facing with his software 2 years ago, and they couldn't make progress. But now, you know, that he got into how these AI tools can help him do more stuff. So he's able to, you know, look at these contracts and be able to find problems in them automatically with the AI tools that he didn't have. So he was just feeling so good about himself that he sees these amazing tools coming to the picture that are simplifying everything, right? And you're able to start touching domain and innovations you never thought is possible, right? And it's not going to be, you know, the key thing for you. You know, when I was growing up, it's all, you know, we had to deal with hardware, you know, just literally, when I enter commands, I have to do, you know, buttons up and down, right? And then next, I enter them by hand, and then I run the program. It doesn't work. Then I have to do it again. Enter, right? Then we had to do cards. But for now, you're gonna just have incredible capabilities to do stuff that you never thought possible, right? You know, the other day I was working on generating, you know, I'm looking at how to do complicated contracts, you know, using AI. For example, when you have a heavy equipment like a Caterpillar or something, how do you write a contract for it? It involves the buyer, seller, the service company, the finance company, right? And just with AI now, not only that contract, you can generate a 3D image of the whole contract where the problems are, right? So there are a lot of tools, but so the code is going to simplify for you, but what you want to design is going to become key, you know, right? So how you interact with these chatbots is going to be more important than the code you have to write, but you have to be patient right now, right? And go through these steps, and then you will elevate yourself to the design level. And with chatbots, you know, the way you're going to talk to them is to, I want to build an app to do A, B, and C. And these chatbots are going to help you with that, but you have to know what you want. And you don't know what you want until you go to classes like this right now, right? But it's an exciting time. We still have a little bit of, you know, the transition that's happening. We're going from the old technologies, right? That what we use right now, you know, all these techniques you see, right? And we're transitioning to these new tools and new capabilities, right? So things are a little bit slow for you now, but just watch what's going to happen next year and the year before. By the time you graduate, it's going to be a new world for you, with innovations like you've never seen before. Just because the tools that we have, it's not like AI is a brain, right? There's nothing about it. There's no, right? There's no magic. But the tools we use to make things happen are going to become simpler, right? You know, more powerful tool, easy to use, boom. But the output that you're going to get is amazing, and you're going to be like, oh, I can do this, right? So those are what's coming your way. But right now, let's get this. And I feel like this class, right? This class and 5100 are so important for AI, because you need to learn how to think of as a designer. And then when you interact with these chatbots about your design, you're going to get incredible stuff out of it, okay? So today we're going to transition. We have Anu Nwapo. AB is still.
Hi, Professor.
Hey, you're here. Mercy, okay.
Yeah, this is Mercy. Okay, so this time around I tried changing my name, but I couldn't, so I just left it.
Okay, that's okay.
Yeah. Well, based on the assignment, it's still very confusing for me, but I know that I'll still I mean, by the time I continue to do it, I'll understand better. But I mean, it's still like talking about components. And also, I think I got some tips from like the other people here that have spoken, especially I jumped into the code myself, but then I forgot to like do a breakdown of what I'm trying to achieve and what exactly I'm trying to do. So which I'll have to go back and also like, try to see how I can break it down into components as
Okay.
I mean, based on what we've been doing before now, and then see if I can like work on the code.
Very good. Okay, step by step. Fine.
Yeah.
Okay, take your time. We'll get it right. Okay,
All
Mercy.
right. Thank you. Thank you.
Right. Alwasin and Joran.
Hi, Professor. Hi, everybody.
Hey.
I was trying to at least attempt the assignment. In fact, I spent almost 2 days on it because I think the link wasn't giving me access to the repository and all that. So I had to wait till I could fix appointment with Rena, and which we were able to have a way today. So I just had to follow up and at least finish up the assignment to some stage. So maybe later we now sit down and look at what we are doing really, because honestly, the instructors didn't take enough time to at least analyze the whole thing in a way that one we understand, because we're just going from one class to the other, going to the other page, a lot of things. So I am thinking maybe later, maybe after we have done one or two, one might be able to at least understand what is going on. So that's the honest truth.
Okay, so what help do you need now?
Even with the way things are right now, I just finish up with at least I follow up with all the necessary steps we took, and I was able to arrive at where I could. But the problem now is I couldn't even run the program to get the output. So
Yeah, did you ask for help? Do you need help? We can help you.
yeah, I know, because the class is almost time. So maybe after the class, I can fix another appointment with Rena tomorrow to see what is going on in that life. But I earlier let her know that I couldn't run it. So she said, when I'm done with putting all the necessary things together, then we can now look at that.
Okay.
So
Well,
I know I can count on Rena for help anyway.
okay, well, we didn't need this lecture with it, if you're gonna solve the problem, right?
Yeah.
Okay, all right, thank you.
Thank you,
Right.
Prof.
Right. So so today I think will be a good. Remember, we said, the power of the class is gonna be around our ability to model, okay, things correctly, being able to say a real life scenario, understand what are the different components and how they work together. So we're transitioning to a little bit more of an extension how this model is going to work. But at the same time, there's some Java related ideas that we need to focus on. So the array concept of a Java array is coming to the picture. We call it the array list. From Java, there's going to be a walkthrough of how the pattern, this array list pattern, how it's going to work. So there will be some technicality, but also the modeling technique. Both of them are going to play on you. And we're going to take 2-3 weeks to get comfortable with this concept, okay? Before then we're going to transition to, case studies after that. But we probably have 3 weeks to understand how indexing, how you can have many objects and things like that working correctly. Right. So today will be one of those ideas where I want you to understand these 3 design principles that we're gonna follow when we are building a model. All right. So this is today's lecture. I think you see my screens. So creating and displaying many components, right? So not one component, but many components, right? And we're going to learn what that is today. So these are the 3 design principles. Anytime you're building an application or you're trying to capture a digital image of a live situation, these are the 3 design principles that I want you to be good at. Hierarchy, right? How to look at things from a hierarchical perspective. Hierarchy, that means something that breaks down to smaller pieces, right? So we have, for example, a campus is made up of buildings, and buildings made up of floors, and floors made up of rooms, and so on, right? Same thing if we think of a car, right? You have the car, then you have the chassis, you have the wheels, right? You have the engine, you have the transmission, and so on, right? So that's a hierarchical structure where everything is designed in relation to something else. Then the modularity principle is different, where keeping component, specialized component. If you have one component that looks like has a lot of information that they don't relate to each other, then we recommend that you decouple them from each other, right? So remember the idea of a person. So a person can include the address, but we decouple the address from the person because we said the address is more dynamic and the address changes, right? But your legal identity does not change. So keeping, in other words, for modularity, one other way to remember it will be small is beautiful. Keep these components very small, very specialized, and they don't have a lot of complexity, then the code will be very clean as well, right? So that, again, all these 3 design principles are about how to write clean, simple code, no matter how complex the problem is, no matter how complex the problem is, right? By following these design principles, you will be able to build a design that's easy to convert to code. So the best answer to writing good, simple code that's fun to work with will be to have some effective design principle. And this is what you're going to be learning, how these design principles apply to different kind of problems. Encapsulation, each component is going to have its internal intelligence, like the engine, right? All the functionality of the engine are inside the engine component. We call it encapsulation. So every component is an intelligent component, knows how to do stuff, very specialized stuff, right? And this is how information, these are the techniques to look at a real life scenario and capture it as a digital model, okay? So we will practice this, but let's start with the very simple scenario. Businesses sell product to customers. They must organize their products so customers know about them in terms of features, availability, and price. Sometimes a new product gets added, discontinued, or updated. Business needs software to help them manage their products, which we will call the product catalog, right? So this is the problem that we would like to look, right? So build a business application to help company manage their products, right? So I'm going to show you, we're not going to do any user interface, but what I would like you to see is a particular case like this, right? So when we are creating products will be like this. And then when you have many products of the same product, this is what they look like in a table, right? So we not only have one product, but we have many products. They're all, the table is called the product catalog, right? Product name, product price, product availability. That's MP3 player, DVD players, and so on, right? So how to organize the products, right? When I have many products, how do I organize them? Do I have many reference variables, or is there a different kind of a technique? We know how to keep track of a single product through a reference variable. But what if we have many products? How do you keep track of them all together? Where to keep the product? How to find an existing product? How to list them in a table like I showed you earlier, right? So these are the questions when you have a lot of product. How we know how to keep a track of a single product, like I said, right? But what if we have many products, right? So let's look at an example, a simple example like this, right? What do we see here? A Dell laptop, MacBook, Toshiba, HP Light laptop, right? What's common between all of them, right? What's common between all of them? They're all products. That's a product. So what's really common is the lexicon or the language for these is a product, right? So the model for these laptops is a product, right? But when we have many products, what do? We need to keep them in a single container, right? So in that sense, when we have many products, we really have a collection of products. And that's what we call the product catalog, right? A place that holds all these things together in one place, right? So you remember a product catalog, you probably have received a product catalog book from one of these, whatever, Best Buy or what have you, right? You go, you look inside the catalog and you find all kinds of product listed, right? So two things happening here, the individual products and this container that's keeping them together in one place. So what's the information model for something like this, right? So one thing for sure that we need to remember, if we have a container, right, of all these products, we want to be able to add more products in or remove products out of the container, right? So that these are the operations on this container, right? So this is another level where we have to pay attention to what to do with the information, right? So we have to contain them in one place and the ability to add more and remove more from the product. This is what it means to manage products, right? So that's the idea that we're trying to express today. So what's the information model for what we're talking about for many products, right? Is it a product catalog or is it a product, right? Or is it this? Okay. So what we did when we have many products, we decoupled that into two components. The product catalog is referring to products. Okay. So this is how we work with when we have many products. We have the product catalog that's responsible for all of them and the individual products on the right over here. So this model expresses this idea that we talked about earlier, right? Right? We need the product catalog, right, to represent the container, and then the individual products to represent the product, right? So that is the model that will describe many products. Remember what we said? The company has a product catalog, which means, they have all kinds of product listed in the catalog, right? And this is the model that's going to do this for us. Okay, so we decoupled the many product into two things. So now how do we read this relationship? Look at it, right? The product belongs to the product catalog when the relationship goes from right to left, right? The catalog has products when the relationship is going from the product catalog to the product, right? So that's this connection, this line that you see between the product catalog and the product has a meaning. One direction means something, the other direction, it means something else, right? The catalog has a product. Is it one? Is it 2? Is it 3? It can be many. But the model for it is this. One, we're going to have one product catalog object, and we're going to have many product objects. But they're all linked, connected to the product catalog, right? So this is now extension. Remember, before we talked about a person having an address, right? And when there were 3 addresses, we had 3 relationships because they're different. They're playing different. But in this case, they're all the same, right? Whether from a Best Buy perspective, for example, it doesn't matter. They're all products. So that we stick them in the same catalog in this case. But this is now what we're learning. What's the meaning of these models? What do they capture? These catalogs capture many products, right? And we need to learn how that works now, right? Right? So here we go. Look at these 2 components now. One component has some responsibility. The other component has some responsibility, but they are connected together. You see, now we decouple all these products into 2 things. One is the manager, and the other guy are the people, right? Look at the responsibility of the product catalog, right? Let's go back and look at the responsibility of the product class, right? It's specific to a product. It has a price, availability, and description. That's all. This single product component will have these 3 attributes in it. If we have many of them, we will have many products. Each product will have the whatever, the price, the name, the description, or what have you, right? But look at the product catalog. It has, hey, I am not the product. I am the manager of all these products. Look at, I can create a new product for you. I can add a product to the current list for you. I can help you find and remove from the list. And I can help you find and update specific product. Aha. So the product catalog knows about the group, right? While the product describes a single product, but they're both connected, okay? So this is the new extension that we're getting into. And this is now going to be the foundation how to build incredible models moving forward, right? So we need to master this idea. We're going to practice it. We're going to see many examples of how these 2 components are working together, okay? But look at the responsibility. One component is able to manage the product. The other one is describing individual products, right? So are there other examples? Yes, right? Look at the other examples. A catalog is made up of resources. A course catalog is made up of courses. A car catalog is made up of cars. Okay? That's how when we have a lot of cars, we need to have a car catalog component that knows about all these cars that you have. Look more. Patient visit history. Made up of what? Visits. So the patient kept going back, right, for visits. So there will be many visits. Aha. So we have a component that keeps the history of all the visits. So what are the responsibility of the patient visit history? It can create a new visit for you. It can update a visit. It can remove a visit. Okay. Look at the course schedule. Look at different names, right? Look at the different names, but they describe many ideas, many visits, many scheduled classes. Look at the medication history. When you have a lot of medications, right? We need a medication history that has what? All these medications. That's the model for how to create data, guys, right? But the pattern is the same. Different context, but the concept is the same. When I have a group of objects, this is what I need to do. Call it a history, call it a schedule, call it a catalog of any sort, right? Right? Okay. Alejandro.
Yes, Professor.
Anything that got your attention here?
Well, yes, it's pretty much understanding how we can structure or tackle. Maybe in this case would be the requirements of a client. Maybe he has a store and he wants us to give him an application which can handle all his products and can display them, but also he wants to manage each product individually. So we have to look for relationships between the objects and what they belong to. So
Okay.
this is like what I'm seeing here is perhaps seeing like how we can group individual objects into greater I don't know, spaces, capsules that holds each one of those products, and that can it can help us in a more in an easier way to manage each one of the individual objects.
Yeah, if all of them have a price and have availability, you don't care what's a Dell, what's a Lenovo,
Yeah.
whatever, right? But at least find me a Lenovo that's less than $500, right? Okay, good. Thank you. William, you followed?
Yeah, I think this goes back to what I was talking about earlier too, of just like having a prior understanding of grouping and categorical grouping. Like this makes sense. Like honestly, I want to like try to build some like complex. I want to try to do some complex stuff with Java at this point. Like to see like some complex groups, like with a lot of classifications. Like that. That's to the point where like it seems like
Yeah.
yeah.
Yeah. Okay. Exactly. It's this idea. Now we can build a whole world. Okay. That's all you need, right? A group inside the group, right? Right. But this is another tool that's coming to the picture, right? From a modeling. When I have a group of similar things, you need a manager for them. So you can add to it, you can remove, you can find, right? This is basically three things: create, search, right? And list. Create, search, and list. Medications, create a medication, list the medication, search for a medication. Patient history, right? Create a visit, find a visit, right? List the visits. All of them are going to be like this. They're going to have three operations, whatever it is, right? A course catalog, same thing. Create a new course. Find me a course. Give me the list of all courses we teach, right? And now we're going to learn how this catalog component is going to do that, right? But the modeling technique is like this, all right? Good, all right? So I'm not losing you guys, all right? So now we continue with that story, right? But remember the modularity principle? It says decouple, specialized components. Oh, you're specialized to tell me information about that visit, right? One visit, give me all the information about who was the doctor, when did it happen, right? What did the doctor say, right? But when it comes to creating visits, finding a visit, that's to the visit history, right? So now it gets more interesting. Look at these patterns now. A fleet is made up of aircraft, right? So an airliner they don't call it a medication history in the airline business. They call it a fleet. A fleet of what? A fleet of airplanes, right? So the group idea is the fleet. The individual component is the aircraft. But look at more. The flight schedule made up of what? Flights, right? So when I have a schedule, that means I have a lot of flights. This is the model for it. So one flight schedule will have many flights, many flight objects. But this is the class. It's called the flight. But when we create a flight schedule object, then we can create flight objects. The flight schedule is going to create them and it's going to keep track of them, right? Look at the flight. The flight will have seats. Is it 1 seat, 2 seats, 3 seats? It doesn't matter. This model tells you you can have, every flight can have as many seats as you want. That's the information model for it, right? But when we create actual data, right, we can have as many of the same thing, right? So again, the same patterns. When you have a group of things, you need to decouple. Managing the group is individual from the individual, is different from the individual elements, right? So that is, look at the connection now, right? Fleet made up of aircrafts, and each aircraft has a flight schedule made up of flights, and each flight have seats. Ta-da! Right? Now you have a hierarchy. The fleet is made up of airplanes, and each airplane has a flight schedule made up of flights that have seats. Right? Look at how organization works, right? This is information, guys. So this is a rule how to describe information, but you have to organize it correctly. And this is where hierarchy is coming in now into the picture, right? What will be higher level than a fleet? The airliner. The airliner has a fleet of airplanes, and each airplane has a flight schedule made up of seats. We want to fly someplace, right? So how to schedule flights, how to buy a seat, right, is all connected to this structure, guys, right? So look at it. So here's the model. A patient has a patient visit history made up of visits. That's the model. This is the rule. Now let's connect it to some real data. So Joe, the patient, is the data. Object is the object. That's an object of the class patient that has a visit history component that has many visits. Here's Anna, the patient, right? Has a visit history made up of base. Look how much information we know about these people, right? So that's the model at the top. This is the data generated from the model, okay? And this is the power of these models. As we progress, our discussions are going to be around the models themselves. And when you program them, you're going to see the data. So how does that happen is what we're going to be practicing next. Look at this model. Airplane has a flight schedule and made up of flights. This is what the data looks like. An airplane, Boeing 787, has a flight schedule, and these are the flights. Okay, the same thing, right? Look at the data generated from this model, right? So we need the model, we call that the design, and then when the system is running, we're going to generate the data from these models, right? Now you add another component. Look at the hierarchical structure here, right? You can say, this is not how we like to organize our life. If we want to organize information, we have to see it clearly, so we know how to schedule a flight, right? So you've got the fleet, and there are a bunch of airplanes, and each airplane has its own flight schedule made up of flights, right? So the fleet is managing a bunch of airplanes, okay? And this is the structure that we need to learn how to work with in this class, okay? Right? So how do we do this in Java is the next piece, right? So let's take a 5-minute break here, and we start getting into the how this will become Java code now, right? Is the stuff that we need to practice before we start getting into more complicated modeling. And I'm gonna give you a little bit why this stuff is significant very shortly. I'm gonna show you some very complicated models that we need to learn how to read them, right? But at the same time, this concept here, by showing one single how the product catalog is going to map to Java code, you can link anything you want after that. So again, we showed the idea of hierarchy and modularity. Modularity because we're decoupling things, hierarchy, how to think of, if you want to build a flight registration system, you need that hierarchical structure so you know what you have, right? Find me a flight to London. How do you do that, right? There's a structure how to find that, right? And these are the fundamentals of building these applications. But let's take a 5-minute break and we'll continue.
Hello, everyone. Please complete today's attendance.
Okay. So how do we do this in Java, right? Let's see. Right, so we've seen the idea of a product and a product catalog, right? And everywhere there's a group of something, right? But also they are linked, right? So the surprise thing is that It's not just a product catalog, right? But now we can continue to expand, right? We continued, right? So the fleet is made up of many aircraft. The flight schedule is made up of many flights. The flight is made up of many seats. But when we connect them, look at the story we create, right? Individuals. Flight has many seats. Flight schedule have many flights. Fleet has many aircraft. But at the same time, look what we get, right? Look at the story we get, right?
Professor, I think you're not sharing your screen.
Okay, sorry. Right? I was just saying, we looked at this model, right? Look at the, right? We looked at these things, right? What did we say, a fleet? We started with what? We talked about this one, right? We said we have a product catalog is made up of many products, right? So this is how to describe this idea of many products, right? We said we need a container for the actual objects, right? This is the pattern. We said, look, this is not only that, but and again, we said the responsibility for creating the new products, right? Or create a new flight now, or create a new visit. Find me a visit, find me a flight. Exactly the same thing, right? So this has one too many, one too many, one too many, right? Same thing. One too many, one fleet, many aircraft, one schedule, many flights, flight, many seats. But we said there's also another story. What if we connect them all together, right? What kind of story we get? We got this. An aircraft now, right, has a flight schedule. One, right? Let's say one flight schedule, right? But the flight schedule has many flights, and the flight has many seats. And we said, this is the, right? Now look at the organization we have, right? So now if you go to JetBlue and say, I want to fly to London, right? Or I want to fly on this particular kind of an airplane. That's a navigation of this model, of this data structure, right? So we use this model to look at the data that we have in the system, right? For you to be able to find a flight going to London, right? So that's why these models are important. That's why it's important that we organize these components to tell a story, a complete story, right? Because when the data is generated, then we want to search. We want to be able to create more flights. We want to be able to add more airplanes, right? But these components, each component is going to play a role in doing that kind of thing for you, right? So those are significant, and that's what we need to learn, right? Is how to do this kind of thing. So how does this stuff become in Java now? So we need classes, so we define what each class means. For example, flight handles the smarts of how to deal with empty and available seats. Objects, so we fill them with data that distinguish things. And array list to do two things. And this is the Java concept that we need to practice to make that amazing model work in the right way, that we can build the model and generate the data and then search the data for the flight or the class or the, right, or the medication or what have you. So array list is one key Java idea that we need to practice, right? And we have a lot of things. So that the array list is a Java idea that's going to glue components together for us. So we get a complete map of what's going on, right? And why that's important, right? So arrays to do two things, like we said, glue components together, relate one component to many components. For example, an array is needed. a flight to house many empty seats. Medication history to keep track of multiple medications for a patient, right? And how that is, so we need to define Java class for the product catalog. We need to define Java class for the product. The product catalog class must keep track of products. How? Right? So this is the implementation logic that we need to learn. Right? So learning these relationships and how to glue things together is going to be very meaningful, but I want to explain to you why that's going to be important and what are the skill sets that you're going to be building in this class. Right? We're not interested in small component, we're interested in the whole system. Right? Look at this model. This model tells a story of a department that has a course schedule. A department that has the students. The students have a transcript. They take classes, right, from the department. Okay, so this is all connected story. On one side, the department has a schedule made up of courses, making seats available, and students take these seats. That's how students sign up for a class. Also, the department has a course catalog. Look, it has a course schedule and it has a course catalog, right? And they're connected. For each course, there are many course offering. So we're going to learn these techniques. We're going to study these models and become comfortable with how they work. Because at the end of the day, these are the rules how you're going to generate the data and work with the data for the department. And look, and then we can navigate. This connectivity will allow me to find something like calculate total earning from course by semester. It's navigation, all these relationships to find all the seats that are occupied by students to figure out the total revenue for a department. Right? The same thing, right? If you want to know, the student tuition, you start from the student account and you work your way to figure out all the classes they signed up for. So these connections, these relationships, when you have this component connected in a big time way, it's incredible the intelligence that we'll be able to get. But it's a lot simpler than that. Each component is going to do a piece of the work. You just ask it and it's going to give you more information. We're going to learn exactly how each component is helping gather the information that at the end become a big summary, big picture information about the whole system. So our idea in this class, guys, I want you to learn what it means to be a software engineer. To be a software engineer, you need to be thinking that you have a system. You're putting a system together. You're not writing programming code. You're writing a registration system to make it easy for students to register and know what's going on in their classes, right? There are many facets. Look at this model. It tells a story from a department perspective, and it tells the story from the student perspective and how they intersect together, right? So that's our sense or definition of what an application is, right? But we build it by building component structure. This is an e-commerce model that talks about products. You have a product catalog made up of products. There's market offers based on these, their orders and stuff like that, right? We're going to get into this story as well. So we have two major case studies. You did how to build a digital university and how to build an e-commerce system, a shopping cart that has amazing story around it that we're going to be looking into, right? And the same thing, this is the UML diagram for the same thing, right? So this is the product class, right? It has, in this case, name, price, availability, and description. We call this the attributes, and then the methods for getting in and out of these products. And look at the product catalog, right? So the product is very boring. It just has these attributes and how to push data in and out. But the product catalog class is different. Look at how we do that. The product catalog has a name. last updated description, and look, list of products. List of products. That's how we keep track of our products. So we have a product catalog component, and it keeps track, not a single address anymore, but no, a list of products. How many? Could be 0, could be 1, could be 100 or 1,000. But this guy has an access to all the products in the catalog. And the implementation is a reference variable called products but now it's not the product, it's a list of products. And we're going to describe exactly what the list is in Java. Okay? Step-by-step way. A look at the new methods in the product catalog. New product is a new method, right? And then we have find the product. This is the search. And then give me the list of product. These are the 3 major operations that are associated with the product. Remember how we define the product catalog? It will help you create a new product and boom, add them to the list. Find me a product by this ID, go to the list and search among the list for the product you want. Or give me the list because I want to print them out. And this is what we need to learn next 2-3 weeks, how to make these 3 methods work correctly in Java, right? So we have time, we'll do it step-by-step way, but this is your next level of a challenge. Once we master this, you can build anything you want. Because the same technique, a new medication, find medication, give me the list of medications, right? Create a new visit, find me a visit, give me the list of visits, right? Find me a flight, a new flight, find me a flight. Everything is the same. So it's the same technique for all of them. But we're going to create incredible stories that way, right? So let's look at, this is what we're doing, right? We're going to look into exactly how that looks like, right? So for example, the person class has a first name. We said we have getter and setters for it. Has a last name. We have a getter and setters. We have date of birth and an address, right? And that's a product. And now look at this. Look at this, right? Product 0, product 1, product 2, product 3, and so on. So that's indexing now. Do you remember the list of products? A list of products means product 0, product 1, product 2, and so on. Each product, each index represents a product. Look at the first product. The price is 1,000, there are 120 available. The name is laptop model 101. The make is Dell. Product sub 1, right? It's very different, right? I don't have the details here, right? But each one is represent a different product. But we keep them all as part of the product catalog. What is that? A list of products. Look at this. Car catalog. Car sub 0, car sub 1, sub 2, and sub 3, right? What's inside, right? So this is the 0th element in the list. It has a product that costs $10,000, 120 available, and so on, right? Then has another product sitting at location car sub 1, another car sitting in location car sub 2. And this is now the index or the list of cars that are saved as part of the car catalog. And that's how information is organized and managed, guys. And you'll be doing, it's a simple idea. We're going to practice it, but you're going to be doing amazing things with it. Look at the flight. A flight has many seats, remember? Seat sub 0, seat sub 1, sub 2, and so on. right? Or we could have done, say, seats, right? And this is what we mean by the array list, by the way, right? We said we need the array list to keep track of what? The flights here, right? I have this flight, I have this flight, I have this flight, and so on. But we need a list, and that list is going to be indexed with 0, 1, and so on, right? Again, look at the JetBlue has a fleet, airplane 0, airplane 1, right? So the airliner has a fleet, right? Which has the airplane made up of this, okay? That's the model for it. Flight schedule the same way. Flight sub 0, flight sub 1, flight sub 2. Okay. All right. Look at the medication history. Medication sub 0, 1. That every one of them is a medication, but they are different medication. The component is the same, but has different kind of data, right? And that's how we organize information, guys, right? So I hope I didn't go too fast here, but I think I got the idea that I want to get them in your head is, right? There's a rule. Maybe I skipped this a little bit. Remember what I said? This is the list of products, right? It's an attribute that we have to create and to keep track of this. So how do we make that in Java? Here's the new method that we need to learn first. Use Java new operator to create a new product object, saves it internally as part of the list, and return the object. So these are the rules for creating a new products. And so let me see if I can share with you. Okay. Right, so this is not, all right. I'm trying to find if I have an example. Okay. See, that way I don't have to, okay, so here's let's look at the product class, right? Here's the product class, has a name, ID, and a price. We can do whatever you want over here, right? So this is simple product class, and set product name, get product ID. Here we generate unique IDs, right? So we can talk about this more detail later. Yeah, so this is self-explanatory. Right? So every time you create an object, a product, it's going to get a new identification number. But look at this now. The product catalog has the name, has a name, but has a product list of type array list. So this is the new thing we need to learn. This is how we implement the list of products. We need something in Java called the array list, and we put between angle brackets what's going to be inside the array list. It's of type products. Only products can be inserted inside this array list. Okay. So that's one thing. When we declare this list, we need to declare it as an array list. So we need you to learn how the array list works. And then in the constructor, you have to create the array list this way, right? Because it's really just a reference variable here. It doesn't have any data yet. But when you create the object in the constructor and and calling the constructor, you need to create an array list and assign it to the product list over here, right? So these are the rules we need to. This is, I'm not expecting you to follow everything over here, but there are rules here. There's a pattern that will apply to any kind of a schedule, catalog, or what have you, right? So rule number 1 is to declare the array list like this to make sure it's available through the initialize it correctly through the constructor. And then remember we said the product catalog is responsible for creating a new product. Bingo. So this creates a new product, right? So we do it inside, right? Right? So all the user need to do, right? So if you have a product catalog, right? So you can say product is, so if we can create reference variable product, we say product catalog dot new product, using exactly del, right? So this is exactly how we would have done it. We use the product catalog, and then we use this method to create the product, and bingo, we have it back. So here's how we create the product. We save it in the list and we return it. These are the rules that we need to practice right now, right? So if you, there are different ways to create a new product, and then we have find the product. There's a method how to find the product. So we need to learn these rules as well, step by step for now, right? So this pattern, we have a recording, we have a video that will go through different ways of implementing the array list. I'm sure Rina will share that with you, and you say the patterns are exactly the same. So if you go over here, look at the supplier directory, made of suppliers, right? So supplier is a class, okay? And if you go to the supplier directory, we have an array list of suppliers. Here's a new supplier, and here's find supplier. Exactly the same pattern, right? As Java is concerned. So I don't want you to get too nervous about the different ways of doing stuff. No, this is a pattern that applies to any group. The name is going to change, but the idea of creating a new, doing the right array list declaration, creating a new object, finding an object, and listing the object are the 3 major operations you need to do for anything to do with the group, right? And that's probably a lot for today, guys. I'm gonna keep it at this. Uni?
Hello.
Yes, what got your attention in this? Anything in particular got your attention? I know there's a lot.
Yeah, that's a lot. I think I need to like practice more to process it, because I think that the last part, the code is difficult, to be honest.
Okay, well, you're just looking at it for the first time. It's not difficult. It's standard, right?
But when
it's a pattern.
when I'm writing by
Go ahead.
myself, but when I write by myself, I think, yeah, this is difficult.
Okay, all right. But you're gonna go through the lab, right? You're gonna follow the lab slowly, step by step, right?
Okay, yeah,
Right.
I will.
Right. Right now, you're not ready to write code. Just you need to go through some of these examples, watch what the rules are, what the pattern is for now. And look at different ways. What happens when you do medication? What happens when you do product? What happens when you do visits? Right? Go through them first and then start one your own. But the pattern,
Okay.
once we master this pattern, nobody can stop you. Okay.
Okay.
Right. Yeah. No, I know it's hard. We're gonna spend time on it. Okay.
Yeah. Yeah, I
Good.
will. Thank you.
Thank you. Yeah.
I think I'm starting seeing like the systems as a story, like how to generate data from models, how to manage those objects, like each of them individually, and also define like how they relate to each other. And also we should like keep in mind how to like keep those components small. Like as you said, small is beautiful. Yeah, and
Okay. Good observation, Aya, right? That's what we need right now to understand. Okay, now we see the process, right? There are a lot of pieces we need to practice next, right? Good observation, Aya. Thank you. Right? How? How Shun Tang?
Hi,
Yes,
Professor.
Professor.
Yes.
Are you calling me?
Okay. Okay. Han Cheng, go ahead. Go ahead, Han.
Calling me?
Yes, go ahead. Yeah. So what was your impression, Hao Shen Fang?
So so I learned a lot. It's a little complicated from the understanding level, but I learned about the catalog. It's like like you are a writer. You are writing a novel and you have many titles. You have title, subtitle, titles, and different levels one by one to the next, right?
Nice. Nice.
And
Good example. Yes. Yeah.
but like everybody's saying, it seems like we understand from the lecture, but when we implement to the coding, it's a little bit, confusing.
Step by
So
step. Step by step.
yes, but from this class lecture, I think it's much more vivid to see how these structures to implement and interact with each other.
So like, now I know what the rest of the class is gonna be like, right? That's basically it. This is it. This is what you're gonna do the whole semester, right? Just see the whole thing, and when these components glued together like this, right? So just a huge thing is gonna be telling a story, which we call the system, like Aya said. Okay, how good. Thank you. Don't be intimidated by it. You have to practice, right?
Yes, thank you,
Okay, good.
Professor.
Thank you. Han Xing Fang.
Yes,
There you
Professor.
go. Yes, give me your impression.
Yeah, I think understanding the concept is quite important, but yeah, also need more practice because coding need a lot of these details things. Maybe when we actually practice it, I can understand it more.
Okay, good. You will. You will. Thank you. Alejandro.
Well, something I take from this class is always if we have a coding project, always begin with the structure. So never start with the coding. Always look at the structure, see what the relationships are, and what groupings you can make as well. So that will make it much easier for the code to actually be written and work as well.
Yeah.
Just like the bank account problem as well. So
Right.
if we lay everything from the beginning, it works. It's much easier to go that way.
Right. Yeah, we're separate. There's a lot of thinking, right? When people program, they are thinking while they're programming. We say, no, 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 right? Take the thinking out. That's your model.
Yeah.
And you make that the code. But it's very dangerous when you're thinking while you're programming. Your code become a big mess, right? So
Yes.
this is, right? So the whole strategy here, guys, to make programming fun and easy, right? By having you put yourself in control this way. When you're coding, you're in control because you're following your model. You're in charge. Here's the model that I'm trying to implement. And now I'm going to see it, how it becomes code. So you have a method, right? But the traditional computer science building code, let's build a function, figure out what to do, and then we go back and fix it later. No, you need to be like an engineer. An engineer always have a map, right? Iman? Thank you. So what's the takeaway, Iman?
Well, I think everyone covered all the points I wanted to share.
Oh,
But I
good.
guess,
You saved yourself time, Iman. No, that's not an excuse.
yeah, but I think the main point is to have a proper design prior to coding. This is like the biggest takeaway from this class, because I didn't think about it that way. And also it's nice to see the bigger picture, to see the catalog, to see a proper system being designed, rather than just a very simplified version.
Excellent. Fine. Thank you, Iman.
Thank you.
Okay. Ulwasan.
Hi, Professor.
Yes.
Yeah, what I could take from this lecture is that now I know we are trying to simplify the structures from the beginning before we get into the coding, by first understanding that there's a catalog that happens to be like a funnel where it houses different products. Then we can now also understand what relationship it has with this individual's product, and how we can narrow the information down in such a way that when we eventually put it into coding, we don't run into any problems at the end of the day.
Good.
So,
Good. And we save time that way, right? So we don't need 2 days to do the code.
oh
Maybe
yeah.
one, right? Next time. Yeah. Yeah. So when you say we don't, it takes whatever time when you're learning, when the students tell me, oh, it took me 2 hours to do this, say that's you, that's for yourself, right? Right?
Yeah.
You know, a lot of learning, right? A lot of the learning when you're doing this kind of thing, what you think, you know, what you think is a waste of time is not a waste of time. It's actually a reflection, observing. You know, that's how learning happens. It's not a waste of time, right? Just different, right? You're building experiences that way. You know, there's more to the profession than knowing how to do stuff. You have to feel it. You have to build that passion because you need to enjoy what you're doing. So the stuff you and your learning is one thing, and that's how you be effective and successful in life, right? When your emotions and your mental mind are all connected together, this is just what make you who you are, and that's what makes people attracted to your capabilities and intellect, and they want your help and want to work with you, right? So failure when it comes to programming is not failure. It's just like another way not to do bad, not to make mistakes, right? Right? Very good. Okay, Mercy.
Hi, Professor. From my end, I think what I kind of understand is when you have a problem, try to understand what the problem is first, and then build an information model after understanding the problem. Building an information model first make you understand, okay, what am I going to do, and how can I build like the information model is going to give you also like a direction of how you build a product catalog.
Exactly. Right. And in the future, how you use AI to finish the code too. Right. So that's, I think, if we can get the modeling technique out of this class, that's going to be plenty. Right. But it's not, you have to see many examples, right? The whole semester, we're going to see many cases, by the way, but this is the starting point. Good. All right. Giuseppe, anything you want to add?
Just that Java's like really relationship oriented. So like when we're going over like the planes, like what's the fleet made out of? It's made out of the aircraft, and it kind of reminds me of SQL, like the structured query language. I use that a lot in my undergrad for databases, especially for like we did it for like a healthcare project, and we were using that to find like addresses, emails, patient names, and stuff like that. So it's kind of like it's interesting to see how they overlap.
Yeah, it's information, right?
Yeah.
Just what happens here with the object-oriented technique, the encapsulation, each component does its own operation. So it's not just table of data, right? You know, all these catalogs are like engines, machines. They create data, they help you find things, they organize for you, right?
Yeah.
So all these catalogs, that's what an application is, right? Is you're building the engines to make things happen inside the system.
Right.
And it's localized, right? You know, so the data and the operations are connected. So you have this local intelligence that when you look at all these different local intelligence, you get this global intelligence, right? Meaning you make an order here, another order there, there's a search there, you know, but suddenly you're talking about your revenue, right? Okay. I mean, the same thing like that university model, you know, students, you know, department creates these courses, student register for classes, they assign teachers, and boom, 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 learning is happening, and students graduate.
Right.
It's all inside, right? Inside the model itself. There's no other layer, right? With SQL, you know, that's the data, but then you need to build the application elsewhere. For us, the data and the application are all entangled together. And we think that's better. That's more reflective of social life than data is on one side and then we have functions on the other side. That's how people used to, that's how the typical computer science program. That's not what we do, right? The engine does its piece of work, right? There's no outside piece of engine, right? There's no, you know, wireless outside for the engine. It's all inside, right? Okay, Giuseppe, thank you. All right, everyone. This is a good day. So this is a good picture. So there will be, I think there might be even a recording of this lecture. There's also a walkthrough of the array list patterns, and I show you multiple examples how the array list is going to work. And you need to, that's going to be key. But the pattern is the same. We need to master that pattern, and we're going to glue complete systems that way, right? And we're going to do that through case studies, right? So next, after we finish with this practice, we're going to look at a complete university, digital university all at once, right? And it tells a complete story, and you have to get used to learning. By looking at that model, you say, aha, this is for managing a university. And that's the skill we want you to gather, you know, and at the end of the day, maybe you never have to write a piece of code, but you're going to be driving the project. All right. All right, everyone. Have a good evening. We're here don't get stuck. If you have issues, please speak up, right? There's Rina, and we also have these that can help as well. All right, Iman, get that stuff out of the way ASAP. Right. All right, everyone. Good night. Take care.
Good night, everyone.
Good night,
Thank
Prof.
you. You have a good one.
Bye, everyone.
Good night, everyone.
Thank you, Professor. Bye.
Thank you.